This video is about calculating body mass index, or BMI. We're going to be using this nice formula, the body mass index equals the weight divided by the height squared. And this is a great formula because it only uses two pieces of information that most people usually know about themselves. And if they don't, it's pretty easy to measure. And so it's a nice formula for quickly finding this number for body mass index. But if we want to be able to compare our quantity that we get for BMI to the tables that we'll be able to find online or in other resources, we have to make sure we're using the right units. In this formula, the weight must be in kilograms, and the height has to be measured in meters. Let's just very quickly talk about these measurements in metric units so that we know if we have a number that is reasonable or not. Some approximate conversions are that 1 meter is about 3 feet and 3 inches, a little bit more than 1 yard, which is just 3 feet. 1 kilogram is about 2.2 pounds. So if we think about some common measurements like the height of a human adult, we should expect to see a result that's between maybe 1.5 and 2 meters for most people. Remember, 1 meter is about 3 feet 3 inches, so 2 meters is about 6 feet 6 inches. So 2 meters is about on the high end of the people you probably know in your life. You maybe know a person or two that's taller than that. And someone who is 1.5 meters tall is just a little bit under 5 feet. And for weight, a person who is 50 kilograms would be about 110 pounds. And a person who is 100 kilograms is about 220 pounds. So we're looking at weights for people would be in kilograms, somewhere between 50 and 100, maybe above 100. That would be between 110 and 220 pounds. So I went on Google and I found these conversion factors that we're going to need to convert units to make sure we have our height in meters and our weight in kilograms. And for our example, we're going to use Colin Sexton, pro basketball player for the Cleveland Cavs, who is 6 foot 1 inch and 190 pounds according to his profile on NBA.com that I looked at last night. Let's take a quick look at the man. Before we start converting the units, I think I have to say that Google does a great job of not just providing those conversion factors that we need, but actually of converting units. So I'm a mathematics professional, and if I need to convert units, I'm probably just going to punch it in on Google. But it's important for us to know how we can do these things by hand, and that's what I want to talk about in this video. So you can do it with Google. It's a great tool for converting units. Here's how I would do it by hand. For converting the height, I think we have a couple of options, a few options, but we'll look at 2 of them. So we've got our BMI formula up here, weight over height squared. Let's start with converting the height, 6 feet 1 inches. So the first option I'm looking at here is converting the 6 feet into inches, and I'm using an idea that's like dimensional analysis. So I'm starting with just the 6 feet, I'm going to convert that to inches. So I have this fraction to set up, that's my conversion factor, 12 inches in 1 foot. And I want to set that fraction up so that the units I'm starting with, the 6 feet, are in the denominator that they'll divide out, and the units that I'm trying to achieve, the inches, are left in the numerator. So with this setup, I'm thinking that those units of feet divide out. We're left with inches when we multiply the 6 times 12. So 6 feet with 12 inches per foot equals 72 total inches. Colin Sexton is 6 foot 1, so we're going to add in that extra 1 inch and have a total of 73 inches for height. Now that we've taken his height that was in those mixed units of feet and inches and changed them only into inches, we can convert the inches into meters using our conversion factor. I'm going to set it up the same way as I did converting the feet into inches, starting with 73 inches and multiplying by this conversion factor of 0.0254 meters per 1 inch. And just like before, that's going to have our units of inches divide out, and we're left with the units of meters, which we need for our BMI formula. And that multiplication gives us 1.8542 meters for Colin Sexton's height. Let's take a look at a second option that we have for converting the units for height. What we just did was we took the height and put it into inches only before converting inches into meters. Another option would be to represent the height using only feet. We can do this by just taking that 1 extra inch and representing that as 1/12 of a foot. Because it takes 12 inches to make up 1 whole foot, we have only 1 inch, so the fraction of a foot that we have is 1 inch out of 12. So we can represent 6 foot 1 inch as 6 and 1/12 feet. Now, like before, I'm going to multiply by this conversion factor. This time we need the one that is feet into meters. And I'm making sure that the units of feet are in the denominator to divide out, and the units of meters are in the numerator, 0.3048 meters per 1 foot. Those units of feet divide out. We're left with meters when we do this multiplication, and we'll get the exact same number that we got before, 1.8542 meters for Colin Sexton's height. Either of those options will always work. I think it's useful to understand that we have both at our disposal. So we've got our denominator, the height, that will be squared. We need to get our units for weight changed from pounds into kilograms. So I'm going with the same approach again, starting with 190 pounds, multiplying by this conversion factor, 0.4536 kilograms per 1 pound. It really doesn't matter what conversion factor we use. If you looked up and found one that said that 1 kilogram was about 2.2 pounds, that's legit. That can go in there. All we care about is that those units will divide out. So whatever conversion factor we use in that fraction, we have this many pounds equals this many kilograms. Whatever those quantities are, as long as they're equal. And then in our conversion factor, we need those starting units of pounds to be the units in the denominator to divide out. And we're left with the kilograms that will be the units for our answer. So we'll take care of this multiplication and get our result in kilograms, 86.184 for Colin Sexton's weight. So we've got our numerator, the weight in kilograms, the denominator, the height in meters squared. Let's go ahead with these calculations. My advice is that you would always save rounding until the very end of the problem. So trying to keep all these numbers exact as you punch them in. And when I round, I had no real strong reason to choose to round to the nearest thousandth. I think I wanted to keep a few extra decimal places to make sure that you and I had the same calculation. I think it was like a 0.0676 and other stuff. So a little bit over 25. The next thing we would want to do would be to look up some chart of BMI results to figure out what is the meaning of a body mass index that is 25.068. I mean, when we want to make sense of any number, a good place to start is to think about the units. And our units here, we had in the numerator kilograms, and in the denominator, it was meters that was then squared. So we do have a number that we could say has the units of kilograms per meters squared, but that's not really a unit that we're used to dealing with in our everyday lives. So it's tough to know how to make sense of that number. We do want to compare it using a chart to other BMI values. So I did a quick Google search, found this website from the US government that gives us some categories based on BMI values, and I see that in the range from BMI of 25 to 29.9, that category would be overweight. Let's just take another quick look at Colin Sexton. A 30 or greater is obese, and we also see normal weight and underweight categories in this website. And so based on our calculations of BMI, Colin Sexton is at the very bottom of the overweight category. Now, it doesn't mean the BMI formula is bad, but it doesn't take into account some important other variables, things that we can really see that difference when we look at professional athletes. Variables like percent body fat or muscle to fat ratio. So it's a good formula for being as simple as it is and still very useful, but it does have some limitations.